Hello and welcome to Instructalist Online Tutorials. In this video, we are going to solve problem under atomic physics. Light of frequency 7.00 times 10 to the power of 15 Hz illuminates a metal surface. The ejected photoelectrons are found to have a maximum kinetic energy of 2.3 electrovolts. That is the meaning of this EV. Find the work function and the trios frequency of this metal. So in getting the work function and the trios frequency, we need to consider the photoelectric law that was propounded by Einstein, Albert Einstein. So he propounded an expression for wave function and also photoelectric or photoelectrons. You can call it photoelectric law. Okay, so and that the expression is let's have a solution to this problem first, and then we'll have to state the expression for that to be hf naught equal to hf minus e. So the whole of this parameter, some book can represent this as omega. This omega is representing work function. Either you place it like this or like this. It means work function. And then this could be equal to hf minus e. E is the maximum kinetic energy. And then hf, you have to treat them individually. This h is a Planck's constant and it has its constant value. And then f here is the frequency, is the light frequency. That is this f. This particular f you're having here is what we call the trios frequency. All right, so let's treat it one after the other. I am saying sometimes you may see the work function in this form, or you can see it in this form equal to this, this equal to this. I can represent it in different formats. All right, so the major concern is to be able to use it to solve problem. Okay, so hence we are asked to find the work function, but there are parameters that have been given. So before we make use of this formula, let's bring out this parameter. We have the light frequency, that is this single f to be equal to 7.00 times 10 to the power of 15 Hz. We also have another useful parameter here. Illuminate the surface. Okay, the ejected photo electrons are found to have a maximum kinetic energy of this. All right, maximum kinetic energy, which is E, is given as 2.3 electrovolt. And I would not love to solve with electrovolt. Of course, we know that kinetic energy is measured in joules. It can also be converted to electrovolt. But I want to show you how to convert from electrovolt to volt, or to joules rather. So if you want to convert from electrovolt to joule, you have to multiply. You can say E equal to 2.3 times 1.6 times 10 to the power of minus 19 joules. All right, so I have successfully converted from electrovolt to joules. So if you multiply this through, let me see if I have, okay, let's punch the values we're having there. Just follow me up and make sure you have the same answer I will have. If you're able to get the answer, you can drop it in the comment section, so I will look into it together. All right, times 10 to the power of, we have minus 19. All right, so this will give us the value 3.68 times 10 to the power of minus 19 joules. You can see that I've converted the kinetic energy from electrovolts to joules by multiplying it by 1.6 times 10 to the power of minus 19. Okay, another parameter that is given, we've captured that of the frequency of the light and this, and you're asked to calculate the work function. And that is all. You should also remember that this H stands for Planck's constant, and Planck's constant H has a constant value as 6.63 times 10 to the power of minus 34. You can call the unit as joule per second or kilogram meter square per second. All right, so that is it. We've already gotten the necessary value, the Planck's constant. Some people can have a stroke here, as Planck's constant will be 6.63 times 10 to the power of minus 34. Okay, we're having 35 there. Minus 34 joule per second or kilogram meter square per second. All right, so the next thing we're going to do now is to substitute the values into the equation. So hence we are asked to find the work function at this point, the work function first before the 3 O's frequency. So for the work function, HF naught represent work function. So we have HF naught equal to, what is this H? That is our Planck's constant, which is 6.63 times 10 to the power of minus 34, and that will multiply by the frequency of the light, which is 7.00 times 10 to the power of 15, and this will subtract the value we have for the kinetic energy, which is 3.68 times 10 to the power of minus 19 joules. So HF naught will be equal to, let's do the mathematics. We have 6.63 times 10 to the power of minus 34, and this multiplies by 7.00 times 10 to the power of 15. And if you check the result to this, it gives us 4.641 times 10 to the power of minus 15. If we subtract the result by 3.68 times 10 to the power of minus 19, the result will give us 4.273 times 10 to the power of minus 18. That will be the answer to this particular problem. All right. The second expression or question is for us to calculate for the 3 O's frequency. And from this same expression, you can get the 3 O's frequency, and the 3 O's frequency is F naught. So at that point, we can easily make F naught the subject of the formula. So if we have to make F naught the subject of the formula, we will need to divide both sides by this H. So that way we have F naught equal to HF minus E all over H. Remember that H and H, they represent the Planck's constant, and they have the value here. The F you're seeing here is the same F, this value, and the E is the same value you've converted. So I will leave this space and then progresses to somewhere here to solve the problem. I think I need somewhere better so that we can be able to fix the solution to that problem. Let's take it up a bit. Okay, this we might not want them, and also this. All right, at this point we can have F naught equal to, the H is a Planck's constant, which is 6.63 times 10 to the power of minus 34, multiplies by, you can put it in brackets, your F is 7 times 10 to the power of 15, which is the same thing as 7.00 times 10 to the power of 15. All right. This will minus, this value has been worked on as 3.68 times 10 to the power of minus 19 joules. And you divide this by this Planck's constant, which is 6.63 times 10 to the power of minus 34. All right, so it is simple. It's something that is very simple. I could easily cancel out, but let's go direct to be sure we're in place. So what I'm going to do quickly, I'll punch the whole of the value on the calculator and then press equal to give me the solution, instead of having to write them down one after the other. So what we have first is 6.63 times 10 to the power of minus 34, and that value is to multiply by 7 times 10 to the power of 15, and the whole of this will be subtracted. We have this value 3.68 times 10 to the power of minus 19. All right, and the whole of this would divide, the result we'll have on the numerator is going to divide the whole expression at the denominator. This will multiply by 10 to the power of minus 34, and then we have to close the bracket, and the result will give us a negative of 5.55 approximately times 10 to the power of 14 hertz. So I will leave this for you to fix. If you can be able to drop the solution to this is the solution for the work function. This box is meant for you, the viewers, to drop on the comment section what will be the SI unit, the standard international unit for work function. If you follow the video to the end, drop the solution. Drop what you feel is the international units for work function on this box in the comment section. And please like the video, subscribe to my channel if you've not subscribed. If you subscribe, please stay subscribed, and also make sure you turn on the notification so that by the time I upload new video, you get notified, and share the video if it is interesting to you. So thank you very much for enjoying Instructor Lesson Online tutorials, and see you